Okay, welcome to another Orbiter Spaceflight Simulator video, and this video is going to be a continuation in the cargo transport mission that I'm doing here with the Shuttle A. This is one of the default scenarios that comes with Orbiter 2010. It is located in the Shuttle A folder, and this particular scenario, I think it's called Shuttle A on the Moon. The description of the scenario says that you're going to take this cargo back to the Earth, dump it into the Indian Ocean, and then return the Shuttle A back to the Moon. I don't know that I'll necessarily complete all those specific parts of the mission, but I'm going to do at least the transport portion. So let me go ahead and switch camera views here, and we'll pick up where we left off. Now in the last video, I got everything set up to head back to the Earth. I decided that instead of dumping the cargo into the Indian Ocean, my goal is going to be to try to put it right off the coast of Florida next to Cape Canaveral. So we'll see how good the targeting is on that. It can't be perfect because, as I mentioned in the last video, once you let go of the cargo itself just enters into the atmosphere and on a ballistic trajectory. It kind of goes wherever it goes. It doesn't have wings, obviously, so there's no way for it to steer itself, and it doesn't have an attitude hold autopilot, and it doesn't have RCS or anything like that. So it really just goes where it goes. You don't have much control over that. So as long as I get somewhere in the vicinity of Cape Canaveral, I will consider it a success. Alright, now for this part of the mission, I need to now, I've just finished circularizing my orbit, so I now need to plan on the ejection coming up here in a little bit. Before I worry about that, though, I do want to get closer to that time. Currently, the TEJ, which is my time to the ejection, is 4,400 seconds. That's too much time to consider setting up, basically setting up a maneuver. So first of all, I'm just going to warp time forward, come around the moon, and I don't have any concerns about crashing into the surface because I raised my altitude all the way up to 63 kilometers, so it's no problem. I want to get at least down to 2,000 seconds before I start setting up a maneuver, so let me do that. TJ is now 25, 24, and we're coming up on 2,000 seconds. Okay, back to real time. Let's go just a little bit more. Alright, there's 2,000. So now back to real time. I'm going to bring up interplanetary MFD on this side as well. And I need to basically copy this plan into the Delta Velocity program. I could fly this plan just like it is. I could actually just go to page, hit the AB, which is auto burn, and it will do a pretty good job of taking me where I want to go. But I know from experience and from all the time I've spent with Dimitri that this plan is about as accurate as Transx would be due to the whole math model concept. So we can improve our plan by not using this and instead using a combination of the Delta Velocity program and map. So I'm going to do that. So got interplanetary on this side, go to the menu. Now I don't want to share anything at this time. Right now I just want to have these are separate instances. They're not together, and that's how I want them for now. I'm going to go to the course program, go down to the Delta Velocity program and hit set. And first order of business projection. Now I basically am just going to run through, there's really only two things here, to set the TEJ and then the prograde, so let's do that. So with the white underline under the TEJ, I'm going to hit set, and then I'm going to copy this number, which is 1905, enter. And it doesn't have to be exact because I will have to make adjustments anyway, but I want to get it close to that number. And now the prograde. Now I could, if I wanted to, before I brought this Delta Velocity program up, I could have taken a look at the burn vector, but this is going to be almost entirely prograde, so I don't really need to do that. I can just put in this whole thing as prograde. So I'm going to go set and 911, and you don't have to worry about decimal points. But to show what I mean, I'll have to actually back out of the Delta Velocity program for a moment. So let me go to menu. Now over here on this side, if I go page and then bring up the burn vector, you can see, and actually I am glad I did that because there's a lot more inward there than I thought there was going to be. So, okay, that's interesting. I'm glad I did that. So what I really want to do then is I want to make a note of what is my prograde, and my prograde is 788.59. Again, we don't really have to worry about decimal points, so I won't. And then the plane change part of it's a small number. I'm not going to worry about that. But the inward is 456. So I'm going to write that down. So I got 788 and 456. Now the reason I mention this is because if I just take that number and put all of that in as prograde, I'm going to be pretty far off. Normally, and I'm actually kind of surprised on this, but normally when you come over here and look at the burn vector, what you'll see is that like 99 or 98% of your total velocity is all prograde. Then you'll have just a 1 or 2 meters per second of plane change, maybe 1 or 2 meters per second of inward. But in this case, you can see it's not just 1 or 2 meters per second of inward. It's a good chunk of our velocity. So it's good that I came in here and took a look at that. Now the reason I had to leave the delta velocity program in order to look at the burn vector is for this reason I'll show you now. Even though these are not shared, there seems to be some kind of glitch with IMFD where when you have the delta velocity program up, there's some sort of sharing involved. So now when I come over here and look at the burn vector, never mind, it's actually showing it correctly. But what you'll sometimes find is that when you come over and look at the burn vector, when you have the delta velocity program open on the other side, you'll find that your DV here is all wrong. It's like zeros across the board or something. And I don't know why that is, other than it's just some kind of glitch. So that's it. That's all I need out of the orbit eject. I have everything I need. I've got the time, and I've got the actually. I did write down these numbers, but I forgot to transpose them over to here or transcribe them. So for the DVF for the prograde, let me go set, and it was 788 is what I wrote down. Then next, and the inward is going to be 456. Okay, now I have the numbers. Now I'm done with orbit eject. I don't need it anymore. So I'm going to go to menu, and I'm going to go to now I'm going to share this side with this side because I want to use the map program over here, and the map program has to get its information from somewhere, and the somewhere that it's going to get its information from in this case is the delta velocity program. So this is ID 1, that means this side's ID 0, so I'm going to go 0, enter. Now this instance of IMFD is saying, okay, I'm going to get my data from here. So now I'll bring up the map program, and I want to reference the Earth because that's where we're going. And I don't have a lot of interesting information to look at here, so it might help if I turn on the display lines, turn off the auto zoom, page over here, and if I want I can have this sphere of influences on, it doesn't really matter. And then I want to turn on the plan. And the plan's now pulling, the plan's saying if we do this burn here, this is where we're going to end up. Now I want to kind of change the way this reference information is, because you can see here I don't have the latitude and longitude, so I don't know where I'm going to end up. So I'm going to hit mod, and now I can see it's saying that if I do the burn, this is where we're going to end up at on Earth, and it's not where we want to be. So there's two problems here, and problem number one is my PEA is 6,000 kilometers above the surface. That's no good. And then my latitude and longitude is wrong. So the first thing I'm going to do is try to get my PEA back down to where I want it, which is about 20 kilometers. So let me go previous, and let me start by changing velocity, because to me it's always better if I can remove velocity as my first course of action, either here or here. Probably actually better to start with the inward, see if I can get rid of some inward. So as I'm taking away some inward, you can see the PEA is coming down, and the longitude's getting farther east, which is also what I want. So that's a good place to start, is just to take out some of this inward. It's making my burn cheaper, and it's also becoming a more efficient burn. So we've taken away several meters per second. Now the longitude is getting much closer to where I want it to be, but the PEA is still quite high. So I think I said about 85 on the longitude. So somewhere in this neighborhood is about where I want to be on the longitude. Off the top of my head, I can't remember what the latitude was supposed to be, like 26 or something. I'll have to look that up. Let me go to select map. Yeah, Cape Canaveral is about 28 degrees north, so that's what I want for the That's what I'm going to want for the latitude. So select interplanetary MFD. Okay, now you notice the PEA is not coming down very quick as I'm taking out some inwards. So I'm going to play with one of the other variables, like the prograde. And I can see as I take away prograde, it's actually increasing the PEA. So I'm going to add in prograde, bring that down. And it's also moving the longitude farther east. So now I'm actually a little bit too far east. So I'm going to just kind of overshoot this a little bit. I'm going to come back to this variable. Right now, these are very rough estimates. I'm just... Okay, I'm now going to try to play with the time a little bit, because I think I've taken away about as much velocity as I can. So as I'm taking away time, it's having the longitude go in the wrong direction. So I'm going to add in a little bit more time. Let me just double check on the map real quick. Let me write these numbers down. So 80 west. Actually, let me do 80.6 west. That would be, exactly at Cape Canaveral, but I think I want to have it back here somewhere, so more like closer to 90. And then 28.5 north. Okay. All right, now back to interplanetary MFD. PEA. So let me get my PEA set. I'll worry about the other numbers here. I got to get things in the ballpark, and right now they're not really close. Okay, so that's ballpark PEA. It's not low enough yet, but I'm leaving myself some room for some alterations here. Okay, now as I'm adding in DVI, it's moving the longitude further west. It's bringing down the PEA. Sort of. Actually, now it's taking it up. Alright, let's see what we can do with time now. So time is... it's not helping in that direction, so let's take out some time. Let's bring the PEA down. It's having a big impact on the longitude though, so I'm going to have to be a little more careful with that. So taking out some forward velocity. Okay, I'm going to end up raising the PEA a bit. And as I take out time, boy, this is one of them situations where it's just not cooperating very well. Like in any direction you go. I'm just getting reasonably close on the longitude there. I may also go prograde, just because the burn's going to be coming up, and this thing maneuvers so slowly, I don't want it to take forever to get into position. Okay, PA's coming down. And a little bit on the inward-outward. It's mostly going to be time and prograde, and that's usually the case. Okay, we're getting pretty close. So now the PEA is at 170, which is still on the high side. But as I add in a little bit of time, I'm getting the longitude more where I want. Okay, yeah, this will get it. Okay, the longitude's really close to where I want. Now just a little bit on the PEA. That's really close. Now the latitude isn't quite right. I'm not entirely sure how to resolve that. Maybe some plane change. Okay, longitude's 90. I want it to be not quite that far out. And then now the PEA is pretty close, but I need it to be a bit lower than that. Okay, that's pretty good. Now, let me see what happens with just a little bit of plane change here and there. Yeah, it's not having hardly any impact at all on the latitude. Alright, let me go ahead and set that to 0. So I think I'm going to go with this burn. Let me just think about it for a second. So the PEA is 15, maybe a touch low. Oh, I got that on 10x. That's why it's making such large adjustments. Somewhere probably closer to 40, 20, 40, a little bit more to my liking. And then the 86 west, that gets me, you know, farther to the west. And I'm hoping that then by the time the cargo containers hit the atmosphere and slow down, they'll go past the coast and fall out into the ocean somewhere. That's the idea. So let me go with this burn. Let me turn off the ProGrid autopilot. Go to page, burn vector, and auto burn. Warp time forward to complete this burn. And then we'll call it apart and move on to the next video. Once the burn starts, I do want to turn the plan off and then kind of keep an eye on it. Make sure everything is correct before the burn starts. So the PEA, this is the referencing Earth, the PEA is 40, longitude is 86 west. I like it. Let's go with this. Okay, there's the burn. Uh-oh. I see a huge problem, though. With that much inward, it might send me into the moon. It's going to send me into the moon. You'll note that as I'm coming around, it's going to put me 600 meters under the surface, so I'm going to have to manually correct that.
Translation, rotation, translation, rotation.
And then I'll have to do a second burn, essentially, to fix this once I get past the periapsis. But right now, this would send me into the moon, so that's not going to work. I wasn't even thinking about that when I saw all that inward. So let me rotate out a bit. At 90 degrees, that'll be the most efficient way to bring the periapsis up. This thing is so slow. Should have started killing the rotation much earlier. Okay. Okay, that puts me a couple kilometers above the surface. Let me turn the plan off and see how bad this messed up everything. Yeah, it's pretty screwed up. Now you can see now my PEA at Earth is 130 kilometers below the surface, and it set my longitude pretty far off. So I got a issue to fix here, but I'll take care of that when I come back in the next part. So I think I've actually practiced this flight a couple times, but this is the first time I've tried to dump the cargo off the coast of Florida, so that's why I'm having things go differently than it was before. Let me make sure I get past periapsis though before I end this video.
You are cleared to land.
Okay, the danger's passed. I am past periapsis, so yeah, when I come back, I will have to do some kind of corrective burn to fix the periapsis and the longitude, and I might actually take care of that after I get out well away from the moon, so that I'm not within the moon's SOI. If you like this video, hit the like button, and if you didn't like it, hit the thumbs down. That's fine. Check for links in the description down below, and I'll see you in the next part. I'm going to do at least the transport portion. So let me go ahead and switch camera views here, and we'll pick up where we left off. Now, in the last video, I got everything set up to head back to the Earth. I decided that instead of dumping the cargo into the Indian Ocean, my goal is going to be to try to put it right off the coast of Florida next to Cape Canaveral. So we'll see how good the targeting is on that. It can't be perfect because, as I mentioned in the last video, once you let go of the cargo itself just enters into the atmosphere and on a ballistic trajectory. It kind of goes wherever it goes. It doesn't have wings. All right, there's 2000. So now back to real time. I'm going to bring up interplanetary MFD on this side as well. And I need to basically copy this plan into the Delta Velocity program. I could fly this plan just like it is. I could actually just go to page, hit the AB, which is auto burn, and it will do a pretty good job of taking me where I want to go. But I know from experience and from all the time I've spent with Dimitri that this plan is about as accurate as Okay, welcome to another Orbiter Spaceflight Simulator video, and this video is going to be a continuation in the cargo transport mission that I'm doing here with the Shuttle A. This is one of the default scenarios that comes with Orbiter 2010. It is located in the Shuttle A folder, and this particular scenario, I think it's called Shuttle A on the Moon. The description of the scenario says that you're going to take this cargo back to the Earth, dump it into the Indian Ocean, and then return the Shuttle A back to the Moon. I don't know that I'll necessarily complete all those specific parts of the mission, but obviously, so there's no way for it to steer itself, and it doesn't have an attitude hold autopilot, and it doesn't have RCS or anything like that, so it really just goes where it goes. You don't have much control over that. So as long as I get somewhere in the vicinity of Cape Canaveral, I will consider it a success. Alright, now for this part of the mission, I need to now, I've just finished circularizing my orbit, so I now need to plan on the ejection coming up here in a little bit. Before I worry about that, though, I do want to get closer to that time. Currently, the TEJ, which is my time to the ejection, is 4,400 seconds. That's too much time to consider setting up, basically setting up a maneuver. So first of all, I'm just going to warp time forward, come around the moon, and I don't have any concerns about crashing into the surface because I raised my altitude all the way up to 63 kilometers, so it's no problem. I want to get at least down to 2,000 seconds before I start setting up a maneuver, so let me do that. TJ is now 25, 24, and we're coming up on 2,000 seconds. Okay, back to real time. Let's go just a little bit more.